Today, we will answer this math challenge. And here's the question. Given this equation, 3x minus 5 raised to the power of 5 minus 2x minus 3 raised to the power of 5 minus the quantity x minus 2 raised to the power of 5 all over the quantity 3x minus 5 raised to the power of 3 minus the quantity 2x minus 3 raised to the power of 3 minus the quantity x minus 2 raised to the power of 3 equals 65. And the goal in this question is to find the real value of x that satisfies this equation. So pause this video right now and see if you can answer this question, because I will show you the solution in 3, 2, 1, and here's our solution. Alright, so first thing is to observe the given. So one way to notice is this expression 3x minus 5, 2x minus 3, and x minus 2. So take note, 3x minus 5 minus 2x minus 3 is equal to x minus 2. Also, we can use 2x minus 3 plus x minus 2 equivalent to 3x minus 5. But I like to use this one because on my scratch paper, when I first answer this kind of question, this is the first thing that I see in this question. So I will stick in this solution. And now, what we're going to do is to replace 3x minus 5 with a and 2x minus 3 with b. So x minus 2, we can replace this with a minus b, their difference. And we will use this substitution to this equation. So we have a raised to the fifth power minus b raised to the fifth power minus a minus b raised to the fifth power all over a cubed minus b cubed minus the quantity a minus b raised to the power of 3. Now, to continue with our solution, what we're going to do is to use some identities. And one identity is a minus b raised to the power of 3. So we can expand this by multiplying a minus b 3 times, or we can use the Pascal's triangle to expand a minus b raised to the power of 3. So we get a cubed minus 3a squared b plus 3ab squared minus b cubed. Also, we also have the identity for a minus b raised to the fifth power. We have a raised to the fifth power minus 5a raised to the fourth power b plus 10a cubed b squared minus 10a squared b cubed plus 5ab raised to the fourth power minus b raised to the fifth power. And now, replacing this a minus b raised to the fifth power with this identity, take note that we can eliminate a raised to the fifth power and negative b raised to the fifth power. They are gone. And also, if we replace a minus b raised to the power of 3 using this identity, we do the same thing. We eliminate a cube and negative b cube. So we end up with this equation. And now, what we're going to do is to focus on this. And on the left-hand side, let's factor out negative 5 on the numerator and the negative 3 on the denominator. And if we do that, we get something like this. So negative 5 factor out and negative 3 factor out. And negative 5 over negative 3 is just positive 5 over 3. Now let's focus on this result. And then what we're going to do is to eliminate this 5 over 3. So to eliminate this, let's multiply both sides by 3 over 5. So we have 65 divided by 5 is 13 times 3. We have 39. And now, from here, what we're going to do is to rearrange some terms a little bit. Let's focus on these two terms. So let's rearrange some terms a little bit. Because using these two terms, we can factor out AB. And in these two terms, we can factor out negative 2a squared b squared. And on the denominator, we can factor out AB. So the result is AB multiplied by the quantity a cubed minus b cubed minus 2a squared b squared multiplied by a minus b all over AB multiplied by a minus b. Now the numerator, we have a factor of AB times a minus b. But on this term, we don't have a factor of a minus b. But Here's the identity for a cube minus b cube. So a cube minus b cube, this is the difference of 2 cube, and we can factor this out nicely as a minus b multiplied by a squared plus ab plus b squared. So we can replace this a cube minus b cube with its equivalent like this. And now, let's focus on this because we can now simplify our equation. So if we divide this term by ab over a minus b, we end up with a squared plus ab plus b squared. And when we divide this expression to ab times a minus b, we get negative 2ab. And now, that is that we can put this negative 2ab inside the parentheses, and we can put this ab outside the parentheses like this. And the question is why we do that? Because a squared minus ab, 2ab plus b squared is a perfect square trinomial, and we can factor this out nicely as a minus b raised to the power of 2. Now, let's focus on this equation. Because now, we have a value for a minus b. This is x minus 2. And we have a value for a. This is 3x minus 5. And we have a value for b, which is 2x minus 3. So we can replace this a minus b, a, and b. Now, let's simplify this result. X minus 2 raised to the power of 2, this will give us x squared minus 4x plus 4. And multiply this, 3x minus 5 multiplied by 2x minus 3, we end up with 6x squared minus 19x plus 15. Now, combining like terms, we have this quadratic equation, 7x squared minus 23x minus 20 equals 0. Now, using our factoring techniques, we can factor this out nicely as 7x plus 5 multiplied by x minus 4. And using the 0 property, we can equate each of this factor to 0 and solve for the value of x. So 7x plus 5 equals 0, we get that x equals negative 5 over 7, and x minus 4 equals 0, we get that x equals 4. And there, you have it. So, using or given this equation, we found two possible values for x. We get x equals negative 5 over 7 and x equals 4. I know checking is very important, but I will leave it to you because if you check this, those are the only real solution for this equation. And as always, we are done.